On page 9 of section 2.2, we'll be talking about parallel and perpendicular lines. So if you have a highlighter, you should get that. If two lines have the same slope, that means they must be parallel. And if you understand slope is how steep two lines are. So if they have the same steepness, that makes sense that they would have the same slope. And that also makes sense that they would be parallel. If the slope of a line is opposite and reciprocal. Oh, so many students think it just has to be one or the other. It has to be both. Opposite means one's plus, one's minus. Reciprocal would be like 1/3 and 3/1. So they have to be different signs and reciprocals. If that's the case, the lines are perpendicular. So here's an example. Positive, negative, 2/3, 3/2. So different signs and reciprocals. So if the lines are different signs and reciprocals, then we call them parallel. So up here, if you wanted an example, you'd say M1 equals 1/2 and M2, which means the slope of the second line equals 1/2. So if the slopes are exactly the same, they're parallel. If they're opposites and reciprocals, they're perpendicular. If they're just opposites, not perpendicular. Just reciprocals, not perpendicular. They have to be different signs and reciprocals in order to be perpendicular. So I'll go ahead and write this in so we have an example for each one. Suppose a line L1, so we're calling that line 1, has a slope of -3/5. Then any line parallel to that would also have a slope of -3/5. So suppose L1 has a slope of -7/2. So this one was parallel. That's why we kept them the same, but this one is perpendicular. So perpendicular, remember, different signs and reciprocals. So this first one's negative. Excuse me. That means the second one must be positive and it's reciprocal, so it'd be positive 2/7. Okay, so those two lines would be perpendicular, which means they would intersect at right angles. That's what perpendicular lines look like. And the lines in 4 would be parallel. They would never intersect. So that's the difference between parallel and perpendicular. Parallel, same steepness, never cross. Perpendicular, when they cross at right angles. So just in case you don't know the vocab, that's filling it in. So go ahead and turn off the video and see if you can do the next two. And then come back and join me and we'll check them together. Okay, so L1 has a slope of 4. This one is perpendicular, so I know 1, I have to change the sign. If this one's positive, this one has to be negative. And I have to remember that every whole number is really over 1. So when I go to reciprocate it, 1/4. So opposite, 1 positive, 1 negative, and reciprocal, 4/1, 1/4. So perpendicular to L1 would have a slope of -1/4. So what is the slope of a line that's perpendicular to the x-axis? So I like these kind because they make you think. So the x-axis is the horizontal axis. And do you guys understand that the only line that's perpendicular to a horizontal line would have to be a vertical line? Because this isn't perpendicular, this isn't perpendicular. The only time it would be perpendicular is if it's a vertical line. So the x-axis is horizontal, so any vertical line would be perpendicular to it. So what is the slope of a vertical line? Did everybody write undefined? Because this one has 0 slope, so the line perpendicular is going to have undefined slope. Because there's no skiing on vertical lines. Next, they want to know what is the slope of a line perpendicular to the y-axis. So if we have the y-axis, the only line perpendicular to a vertical line would have to be a horizontal line. So what's the slope of a horizontal line? I can ski on it, but 0 fun. So the slope of a line perpendicular to the y-axis. So the y-axis has undefined slope, but if it's perpendicular to that, it would be a horizontal line that has 0 slope. So the x-axis has 0 slope. The line perpendicular to it is undefined. The y-axis has undefined slope. The slope of a line perpendicular to it would be 0. So those like really make you think. Okay, here we have 2 points are given for line L1 and for line L2. And they want us to determine whether those points are parallel, perpendicular, or neither. And I just gave this almost exact same question to my 091 class last week when they were doing their Module 7 test. So this is a good one. So first we want to find the slope of the first line. So we'll call that M1. And again, we haven't written the formula 6 times, so let's keep writing it. Second y minus the first y over second x minus the first x. And sometimes students will stop me and they'll go, well, how did you know to do the slope? Well, that's all we really know about parallel and perpendicular. If they're parallel, they'll have the same slope. If they're perpendicular, they'll have opposites and reciprocal slopes. And if they're neither one of those, then they're neither. So the only thing we know about parallel and perpendicular about their slopes, so there's not really anything else we could do. I've had some students in the past draw a picture. You can't tell perpendicular with the naked eye. You need equipment. So this is an exact science. This is algebra. That's why we use the formula. We don't draw a graph, because how can your eye know whether they cross at 90-degree angles or 89.9? So they're not going to be perpendicular unless it's exactly 90. So here's my first x, my first y, my second x, my second y. So second y would be 2 minus my first y, which would be 8, second x, 4, minus my first x, negative 3. So 2 minus 8 over 4 minus negative 3. So I see that double negative, so I immediately make it a big plus. So now that problem is going to simplify to negative 6 in the numerator. 2 minus 8 is negative 6. And in the denominator, it's 4 plus 3, which is 7. So there's the slope that I need to compare to the next slope before I can answer the question. Okay, so let's do this next slope. So first x, first y, second x, second y. So slope of the second line is going to be second y, 5, minus the first y, 11. 5 minus 11 over second x minus first x, 8 minus 1. So 5 minus 11, 8 minus 1. And order matters, so if you start with this y, you have to start with this x in the denominator. Negative 6 over 7. Ding, ding, ding. So tell me about the lines. They are parallel because parallel lines have the same slope. And I have you submit your work on your tests, and this would be what I would want to see. Show me the two slopes, show me your answer. So because the slopes are the same, the lines are parallel. So why don't you shut off the video and go ahead and try the next one. And I will tell you, I'm sure I'm going to tell you this on the first day too, but I took a poll of my students in my 09 class and asked them what was most helpful. What did they learn the most from? They said watching videos. Another one said, actually there were 3 or 4 people that said, I love it when you told us to shut off the video and do it on our own, because you really don't know what you're weak in until you try one on your own. And so I'm going to continue to do that throughout my notes. I try to put 2 or more examples of every kind so that I can practice one and then you can practice one. So that was one of the things students said they found most helpful, is doing a problem on their own rather than just copy everything I say. Okay, so go ahead, shut off the video and try this one. Okay, the slope of the first line is, we'll go ahead and write the slope formula one more time. Second y minus the first y over second x minus the first x. So this is x1, y1, x2, y2. So we're going to have 2 minus 6 in the numerator over 0 minus negative 1. So the first slope is going to be double negative, means turn it to positive. So we have 2 minus 6, negative 4 over 0 plus 1 is positive 1. And I would just leave it like that because it's easier to see if they're reciprocals if you keep that one like that. I mean, you could write equals negative 4. Alex would still count it right. But when I'm comparing slopes, I like to keep the 1 there. So negative 4 over 1. Second slope, let's go ahead and underline this so we know where to look, is going to be x1, y1, x2, y2. So 10 minus 11. So the second y minus the first y over second x, negative 2, minus the first x, 2. 10 minus 11 is negative 1. Negative 2 and negative 2 is negative 4. Ooh, what did our teacher tell us about that double negative? It's always a positive. Negative divided by a negative is always positive, just like subtracting a negative is always positive. So double negatives, positive. So 10 minus 11, negative 1, negative 2, negative 2, negative 4. So the second slope is positive 1/4. So are they the same? Nope, not parallel. Are they opposites and reciprocals? Opposites, yes. 4 over 1, 1 over 4. Reciprocals, yes. So that means the two lines are perpendicular. So perpendicular lines. And there we have it. Okay, we're on our last 20 seconds, so I'll stop here and start the next page on the next video.